Lord, our loving Father, we thank you for this day. We thank you for this moment. We thank you for this time, Father. As we are going to encounter this lesson of math for today, we pray that it may be a success and what is going to be taught, we may grasp it, understand it, and we may put it into practice. For this we pray to the Lord. In the name of the Father, and of the Son, and of the Holy Spirit. Amen.
Amen. Thank you so much. I'm going to disable your microphones, but in case there is something you want to share, I'll be asking you to share with us. How do you raise the hand? When you check on your screen on more there is an icon that can allow you to share, to raise up your hand, and then you share with us. Now, today we are going to start on a given new topic. I understand that your teachers in the different schools are doing all what it takes to say that they complete the syllabus, such that by the time you go in for your final exams, at least you have completed the biggest percentage of it. And therefore, we want to help them as well to finish up the syllabus as quickly as possible. My assumption is that many of the schools, at least they have reached somewhere. You know, some of the schools are doing their best, and at least they have covered the biggest percentage of what you are supposed to cover in your syllabus of math. So when you look at the coverage, I expect that in case your school is behind, at least they have covered up to a given point, and that given point should be on term 1. In case your school is a bit behind, I think they should be somewhere here. But in case you have not yet covered these senior 3 topics, also you shouldn't worry. I know they will do all what it takes to see that they complete up that point. Now, in order for us to be very safe for mock examinations that are coming in second term, we have decided that we are going to start from the last topics, such that the last topic we have is lines and planes in the 3 dimensions. That is the topic we are going to start, such that even if your teachers are still behind, some of these topics, they will cover them, such that by the time you reach mocks, at least you have completed everything you are meant to cover. Because mock examinations will not spare you that you have not covered the given topic, but they will always assume you have completed the syllabus. So to be much safer, we are going to start with lines and planes in 3 dimensions. And then for those who have not yet covered linear programming and maybe loci, then that one, your teachers will help you to cover them. But we are going to start with the last topic, which is lines and planes in the 3 dimensions. And since this topic, everyone, at least you have an idea from your trigonometry 1, trigonometry 2, but also from your senior 2 work. So this is part of the things we are going to do. However, we are also going to be doing a lot of revision in these 3 weeks that we are going to be at home, such that at least we can be able to answer those scenario-based questions that have been set for you people. So on a daily basis, or if nothing goes wrong, we shall be sharing at least a scenario question for us to try, such that we can be better prepared for our examinations. So today, our topic we are going to be looking at is going to be lines and planes in the 3 dimension. So I'll call upon you to write that as our topic, and then we dive into that topic. Now I think everyone has finished. When you look at the screen, I think you can notice that I've displayed something, and those are some of the items we use for the different games, but I can test. You can use the chat and type in case you have met, or the names of those things you are seeing. What are their names? Before we dive into, because we may think everyone knows them, but when actually we don't know. You can type in the chat and you tell us their names, or someone can raise up the hand and then they tell us the specific names for the pictures that are displayed. Okay, looking in the chat, someone is telling us they are called balls. Okay, okay. Okay, yes, all of them are called balls, which is very, very okay. Now, when you look at my screen, the keywords we have here, we have lines, we have planes, and we have 3 dimensions. And that's where we are going to be concentrating on today as we go ahead in our session. But before we dive deep into the session, don't write until when I tell you to do so. So when you look at our screen, I have displayed what we call a 2-dimensional. And now when you look at those 2 dimensions, I want us to type in the chat the different names for those ones. You can say A is called this, B is called this, C is called this, and D. Which specific names, mathematical names, do we give those figures? You can type in the chat. What are the specific names we give to those figures? Okay, looking at the chart, A is a rectangle, square, rectangle, square. Okay, Matthias is saying A is a square, B is a rectangle, C is a circle, and D is a triangle. D is a triangle. Okay, very good. Yeah, yes. Now, what are we going to learn? When we talk about a 2-dimensional figure, that figure can't hold things. Let me say, I'm going to use an example of water. When you have a 2-dimension figure, a 2-dimensional figure cannot hold water. You cannot put water into, let me say, a triangle. You cannot put water into a rectangle. You cannot put water into a square. You cannot put water into a circle. So anything that can't hold something is what we shall be calling a 2-dimensional figure. And when we talk about a 2-dimension figure, another thing we need to notice is that when we talk about dimensions in math, dimensions, we are looking at what we call the length and the width. So when we talk about 2-dimension, it can either have the length, the width. It can either have height or width, but it can't have all the 3. So a 2-dimension means it has either length or width. It can have length or height. It can have width or height. So that's what we call the 2 dimensions. So for all the 2-dimension figures, they'll have any of these dimensions. Like when you look at the square, it can be either length or height. It can either be length or width. It can either be height or width. So it has only 2 things, either length or width and height. And for all these figures that are 2-dimensional figures, we can be able to find their areas. So for figures where you can be able to find their areas, those figures, we can term them as 2-dimension. So 2-dimension, they don't hold things together. They don't hold things. So I'm going to ask you, I want you to raise up your hand. And now as we dive into the 3-dimensional figure, I want you to raise up your hand and you tell us which figure or which item do you have at home, whereby when you put water, it can hold. When you put anything, it can hold. Yes, Noble?
A bucket.
A bucket. Yes, thank you. That is good. Tedoxia.
A basin.
A basin. Very good. Olis. Olis, unmute.
Cup.
A cup. Okay, good. Matthias,
A drum.
a drum. Very good. Noble,
A cup.
a cup. Very good. Now, all those things. Okay, Simon, you are the last. Oh, I saw Simon. Simon,
A tank.
attack. Very good. Now, the next thing we are going to do, I want you to relate, now that you have mentioned a cup, which mathematical figure resembles that item you have mentioned that you have at home? I start with Olis.
Cylinder.
Yes? Oh, okay. Okay, I'm not getting you, Noble. Okay, Noble.
We can have a cylinder for a
Mhm.
bucket.
A cylinder for a bucket. Very good. Matthias.
You have a cylinder for the drum.
For the drum. Okay, good. Okay, yes. Now, those are some of the things. But when you also, I want you to look at these figures we have here, the 2 dimensions. I want you to look at them. When you fold them, take an example. When I fold C, this figure here, which figure do I form? And when you look at the figure I form, can it hold anything? Anyone to share with us as I look through the chart?
Amazing already.
When you look at C, the circle, when you fold the circle, can you be able to come up with any figure, any shape? Yes, Picat.
Semicircle.
Okay, Picat, I'm not getting you. Yes, Picat.
The gund is that? It's a semicircle.
A
When you fold the
semicircle.
circle.
Okay,
Yeah.
when you get a semicircle, what can you hold in a semicircle? Can you be able to hold anything?
No.
Okay, now I want the figure you form, you should be able to use it to hold something. Yes, please. Okay, let me look in the chat. Okay, I want someone to tell us when you fold that circle, which figure, even that item is a bit very common. You love it so much. People at times use it. And those people who play soccer, you can also use that item somewhere. So I want you to think in that direction. Which item can you form from it? Which figure, which other figure when you fold it? Let me check. Very good. Annabella has told us it is a cone. Surely it is a cone. A frustrum, hemisphere, sphere. Okay, yes, we can form a cone. Yes. Now, all those items, friends, that you have mentioned, whereby they can hold something, are what we call the 3-dimension figures. A 3-dimensional figure can hold something. You can put something and it stays there. That's what you call a 3-dimension figure. All these ones that have displayed are 2-dimensional figures. A circle, square, triangle are 2-dimension figures. But anything 3-dimension, it can hold something. When you look at home, someone mentioned they have a tank. A tank is like a cylinder. You can have a sphere. Also, you can have a cuboid. At times when you have a cuboid, I think even you have seen tanks that are made in form of a cube, in form of a cuboid. Also, you have seen that when you have whenever you are wrapping gifts, you can use a box. So also when you look at a box, it is also called a 3-dimension because it can hold something. And when you look at a 3-dimension, it means that figure can have the length, can have the height, and also can have the width. And for it, what you need to know that for all 3-dimension figures, you can be able to find what you call the volume. So any shape that you know that you can find its volume, that shape is called a 3-dimensional figure. So when you look at a cuboid, You look at a cube, all those shapes, you can use them to obtain a three-dimensional figure. Now I want to find out whether we are at the same page. In case you have understood the difference between what you call a three-dimension and what you call a two-dimensional figure, just type in the chat that yes, we can move on to another thing. Yeah, you can just use the chat to type in that we can now move and continue. In case you have understood the difference between the two. Okay, perfect. Okay. Everyone is saying yes. Okay. Yes, so those are what we call, yes, Noble, you have a question, ask.
So, I was just wondering how a sphere is so different from a circle.
How?
Exactly, because how a sphere is different from a circle. I don't know exactly how they are different.
Oh, do you know a ball? A ball, the one we use in pitch. Do you know it? No. Oh, okay. Okay, Noble.
Yes, I know her. I know a ball.
Yes. Now, a ball is a sphere, is a spherical thing. When you put something in a ball, you can that one we call it now a sphere. But when we are looking at a circle is just something that is round. Take an example. It can be what thing is round? Like when you have an object that is round, that one we call it a circle. So a sphere, for it can hold something inside it. But a circle, it cannot hold anything. It's like when you pour water, like when you get your compass and you draw something circular, that one is what we call the circle. If you pour water on it, water cannot be held there. So that is the difference between the two. That for a sphere, for it is a rounded figure, it is a figure that can accommodate something, a figure where you can put something. But when it comes to a circle, you cannot put anything.
Right. I've understood. Thank you, sir.
Okay. Okay, I think we are going to now continue to our next thing. Okay. Now I want you to use the chart to help me to label the different parts you are seeing. So you can type in the chat that A is called this, B is called this, C is called this. You can use the chat to type. What are the specific names we give to those different sides of the figure that we have displayed? Someone is saying us, yellow is called a face. Okay, F4, thank you. A is the vertex. B is the face. I think it is, people have not yet found what C is. C is the height. Sure. C is called the edge. Very good. Very good. So C is called the edge, A is called the vertex, and B is called the face. Another name for a vertex in simple English, you can call it the corner. So when you hear a corner, is what we call a vertex. So vertex is, we use it in mathematical word, but in simple terms is what you call the corners. So when you look at your house, you can note that it has very many corners. Maybe there are 8 or there are 10 and the rest of that. Then the faces is that flat surface. Okay, now I have here some shapes. So I want you can raise up the hand and you tell us for these shapes you are seeing, how many faces do they have? How many edges do they have? And how many vertices do they have? Someone can raise up and you take us through, you tell us for this figure, this is what I'm able to see. Okay, yes, Matthias.
A cube, it has 6 faces.
Okay.
It has 12 edges.
And 8 vertices.
And the 8 vertices.
Okay, very good. Another person to tell us for the prism. For the prism. Any other person who wants to tell us?
Faces. Prism ina faces ndala ibiri isatu ina itano mukaaga.
When you look at the
Mukaaga.
prism, anyone who has identified something for the prism?
Ibiri itano. Ate edges.
Okay, Loslin is telling us that a prism, okay. Loslin told us, yes, the edge.
It has 5 faces.
5 faces.
6 edges.
10 edges.
10 edges.
Edges in
6 vertices. 6 vertices.
Okay, does everyone agree with her? Do we agree with her? Unmute, you can unmute and tell us. Do we agree with her?
Itano mukaaga. Musanvu munana mwenda.
Okay, I think we can count. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. Is there any that we are missing? Yes?
No. 9.
Yes, there are 10 edges.
Mister.
There are 9 edges.
Yes?
There are 10. 10
I wanted to ask.
Is there any that
there are 9 vertices.
Yes, the edge.
Yes.
Are they 9 or 10?
10.
There are 9.
10.
Yes.
They are 9.
Then where are you getting the 10th one?
They are exactly 9.
They are 9.
Because this is 1, 2,
2,
3,
3, 4, 5, 6, 7, 8, 9.
Maybe I miscounted.
Okay, maybe she miscounted. Okay. So that is it. Okay, I'm going to mute you all now again, such that we don't have. Okay. So those are the different vertices and the different. So for these shapes, this is what you did in senior 2 when you are looking at length, and that there's a topic about geometry that you are looking at, and that is what I believe that you did. So now I hope everyone understands the difference between what we call a 2-dimension and what we call a 3-dimensional figure. I want you raise up your hand and you tell us, I want 2 answers. Either to, okay, we are going to use a chart. Either to tell us, the answer can either be, you tell us a 2D or 3D. 2D means a 2-dimension. 3D means 3-dimension. So I want you to look at the figure I have displayed and you let me know whether it is a 2D or it is a 3D. Use the chart and type, and we see who's giving us. Okay. Yes, Michael, you can also tell us.
It is a 3D.
It is a 3D. Okay, good. Okay, good. Yes, Jojo, you joined in late, but we said that 3Ds are those figures that can hold the things, whereby let me say I can use a cup. When you put water there, it can stay there. So when you look at that figure, it can hold something. Okay, good. I'm displaying another figure. Also type in the chat, and you let us know whether it is a 2D or it is a 3D figure. Okay, it seems everyone is saying it is a 3D. Okay, that is good, and it shows people understanding. Okay, I've displayed another figure. You read the figure the way it is. That figure. Okay, Dr. Nakawong is telling us 2D, 2D, 2D. Okay, good. That is very good. So it shows that we have understood. Then that figure I have displayed. Oh, sorry. I think I need to go back. That figure I have displayed, which, okay, 3D. Okay, Annette, Noble, they're saying it is a 3D. Perfect. Yes. Now, when you look at these figures, those people are going to be taking on architecture as your course, or if at all that is your dream course in engineering. When we are drawing plans of houses, plans of things, always we give our paperwork, either using it, we use both, what we call a 2 and what you call a 3. So when someone asks you that he wants to look at the 3-dimensional figure, you present your house in this format. In case it is a 2-dimension, then you show him how big the room is going to be, where each of the different places are going to. So this is how they present when it comes to architecture. Okay, now in this topic, our competence, now you can write what we expect you to know by the end of the lesson. So this is our competence, we can write it. Yes, Tekno, you have a question? Tekno, do you have a question? Tekno, you can unmute. Oh, people are saying they're done. Yes, Tekno.
Does a cylinder belong to 3D or 2D?
Okay, now you tell us, when you put something in cylinder, can cylinder hold water or it can't?
It can.
It can. So which figure is it?
A 3D.
Yes, yes. Thank you. You're correct. So that's how you test them. Okay, now we write our keywords. That's how you test them. For you, test using whether it can hold something. In case you are looking at these other figures, like when you put maybe, let me say you put things inside. Yeah, those things we use to pack things inside, those ones are 3Ds. We write those keywords. When you finish, you can let us know. Okay, finished. Okay. I think, okay, people are finished. Okay, good. We can dive into the topic. Now, our objectives, there are 2. By the end of this lesson, we must be able to apply Pythagoras theorem to the 3D figures. And then the second one, we must be able to find the angle between a line and a plane. So those are the 2 things we are going to aim at achieving in this lesson. So I'm going to ask you to first write that, and then each of you try it for me at this point. After writing, try it for me the Pythagoras theorem. You don't need to write everything, even if you summarize. Okay, good. So when you finish writing your formula, you let us know in the chat that you have finished, such that we can do something. Okay, Annabella has finished, Tekina has finished, Matthias has finished. Okay, we can wait for the rest. I think everyone has finished. Okay, okay, good. Yes. Now, let me hope everyone has written the formula, but remind ourselves always the longest side on your right angled triangle. Pythagoras theorem always works on a right angled triangle. Never use that formula when the triangle you are given is not a right angled triangle. And we know that it will state that a squared plus b squared is equal to c squared. So this is what I expect everyone to have. In case that's what you have, you are very correct. Okay, now we are going to work out for me that number. Work out for me that number. Everyone is trying how to use Pythagoras theorem. We are writing our answer to 2 decimal places. We are writing our answer to 2 decimal places. So just type your answer in the chat and we prove that that is the answer you have. Okay, 8.5. Yes, Tekino? Tekino, you have something to say? You can unmute. Tekino talk. Oh, okay. Okay, okay. Can we have, okay, this is good. This is good. It seems everyone is getting. Now that is where I've seen someone writing 9. I've seen someone writing 9. And that one has issues. 9 has issues, Matthias. And those who have written 8.5, also your answers have issues. And those who have written 8.12, your answers also, your answer has a challenge. Yes, it means that you have not rounded off well. And whenever you don't round off well, it means that you are going to have errors in your answer. Yes, so, okay. Now, they told us write our answer to 2 decimal places. Now, when they say 2 decimal places, it means that the answer you have remained with is what you write to 2 decimal places. So we know that our Pythagoras theorem, a squared plus b squared is equal to c squared. Our a can either be 8 or 3, so it doesn't matter what you have put. So in case you have said 3 squared, plus 8 squared is equal to c squared. Then you go on and say, what is 3 squared? That 3 squared is 9. And then you go on and say, what is 8 squared? 8 squared is 64 is equal to c squared. So 64 plus 9, 64 plus 9, you end up with 73 is equal to c squared. So once you reach here, get the square root on both sides, get the square root on both sides. So root of 73, you are getting your answer as 8.54400 is equal to C. Now, what are you going to do? Now, what you do always, don't round off from the calculator. First, write your answer to many decimal places as you can, and then state your final answer. That my final answer is 8.54, and these are centimeters is equal to C. But our C, since they gave us X, please feel free here, instead of using use X, use X, use X, and use X, since it was already given. So you conclude that my answer is this. When you are counting the decimal places, after the decimal point, when they say 2 decimal places, it means you count 2 numbers, 1, 2. And when you reach here, terminate. But when you look at this number, when you terminate, this number is the number less than 5. So you can't round up. You instead round downwards. So when you round, that is the answer you come up with. So that's how you do that particular number. So for many of the answers that we are going to be dealing with, then, oh, yes, units, when it is, what if it is recurring 8.0, sorry, 8.0, wait, 8.0766. Then for that one, also you terminate basing on where, you terminate basing on what you want. So in case they want to 2 decimal places, then terminate to only 2 decimal places. In case they want 3, then terminate to 3. Now 8.0766, when you look at it, in case they want to 2, I'll count 2 numbers after the decimal point, 1, 2, I terminate. But since this number coming after my termination point is a number greater than 5, all numbers greater or equal to 5, we terminate, we increase the next number to 1 by 1. So I'll add a 1 on this number. So for that case, I write 8.08 as my answer. So the first thing you do, first write all your, before you don't round off from the calculator and give your final answer. First write all the numbers to the decimal places, and then you terminate to the number of decimal places they want you to write your answer to. Hope we are together on that. Yes, M6, yes, unmute.
Good afternoon, teacher.
Yes, good afternoon.
What I was wrong now, what if the number is 8.006? How do I round that?
0.006. To how many decimal places?
To 2 decimal places.
2 decimal places, I'll count 1, 2. Now I terminate. But when I look at this number, is the number greater or equal to 5? So I'll add a 1 on the number coming before it. So this number is 0. So 0 plus 1, I will get 1. So I will get 8.01.
Okay, teacher, thank you.
Okay. What if it is 8.9966? Now for this one, to 2 decimal places, I'll come here. Once I terminate, I'm going to add a 1. So it becomes 10, but we don't write 10. So if you add 1 here, you are going to end up with 8.9, but this one becomes 10. So what you do, 10, you carry on the 1. So when I carry on the 1, the next number becomes also 10. Also, I carry on the 1. So I will end up writing 9.00. Hope that is very fine. Okay. Okay. So I think we are good to continue with the next part. Okay. Now, we write that is going to be our heading. Now, we are going to look at how do we apply Pythagoras theorem to 3-dimension figures. because it's going to be key when we are dealing with three-dimension figures. We are going to be applying them. So that's why we had to first remind ourselves how we use Pythagoras theorem, and then we start. So I want you to first write, our heading is application of Pythagoras theorem, and then we draw that figure. Yes, Maganja Stephen. Maganja Stephen. Okay, I'm failing. Okay, but okay. Maganja Stephen. Yes. Draw. Okay, when you finish. Okay, I think we can continue. Okay, as other people are still drawing. So that is the task that we are going to work on. Now, as we are continuing, one thing is that whenever you are dealing with the three-dimension figures of these figures, once they tell you to do something, always demonstrate it on your drawing. Take an example, they're telling us that calculate the length EG. I want always the first thing you do, go to your figure and ask yourself, where is EG? EG means I'm joining point E to G. Do what the question wants you to do. So I'll come to where E is here, and G is here. Now I'll draw a line like that. That is the line. And now they're asking you, calculate the length. I want you to look at the figure now this is the line they want us to get its length. I want you to look at that drawing we have. I want you to look at the surface down and tell me any two triangles you are seeing or you can form on that surface. You can write triangle this, it. Yes, you can write in the chat which triangle are you seeing. I want you to look at that figure. After joining, someone is saying us EHG, good. We are looking at the triangle, EGF, very good. Yes, if you look very well, you have noticed that we have formed two triangles after joining. So when you join, there are two triangles we have formed. E to G, someone has told us they have formed, there's this triangle is one of them. Another triangle is this one. Now, these triangles we have formed are the ones that we are going to use in order for us to be able to calculate the length they want us to obtain. So visually, when I look at it, in case I decide to use EHG, that is the triangle that I'm going to form. And now your task is extract it. In case you have decided to use that triangle, extract it. Say, I have E, this is my E, something like this. This is where E is, this is where H is, and this is where G is. And I want to find this length here. Then you ask yourself, what is H to G? H to G, they have given me 3 centimeters. Let me ask people, what about E to H? How many centimeters do we have from E to H? You can type in the chat. How many centimeters do we have from E to H? People are getting 3. Very good. So that is 3. And therefore, when you look at the figure you are extracting is a right-angled triangle. So then you apply your Pythagoras theorem to calculate. So let me ask everyone to calculate EG using Pythagoras theorem. Whenever you meet a right-angled triangle, it means you are coming up with Pythagoras theorem. So use your Pythagoras theorem to find out. Okay, I think people already have the answers. People already, okay. When you get your answer, perfect. 4.24, 4.24, perfect. Anyone we are leaving behind, in case we are leaving you behind, you can let us know. 4.24, 4.24, good, 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 good. Okay, I think everyone, Stacy, Daisy, Matthias, Nemwa, Queen, Loslin. I'm saying people have the 4.24. Perfect. Okay, we can continue to the next part, the second part. Don't draw the diagram. Yeah, we are just working out the we are working out. So I want now for this one, I want you to try out. This one, I want you to try out. They are asking us to get A to G. A to G. Let us try. We are trying out A to G. If I still get, oh, you are begging the pardon. Okay. Now we are going to find the length A to G. Now, like we have said, in order for, it is the same question, don't draw it. I'm just giving you the second task. Length A to G. So A to G means I'm going to go where A is and I go where G is. Then I connect. So I'll connect like that. Like that is my simple line. And then you ask yourself, how can I get that length? So someone can say, I'll come down here and I draw like this. I form my triangle like that. That is one approach you can use. So you connect A to G and then find which triangle can I make to obtain my A to G. So the easiest triangle to obtain is to go to A to E, then from E to G. And then you form your right angle triangle. So that's what we are getting. Hope everyone is there now. Let us try. I've seen some answers come in the chat. I've seen, so that is how I have connected, and then extract your triangle. Extract your triangle, and we see what you get. Extract your triangle, and we see what you get. Extract your triangle, and we see what you get. So try, and then you tell us what you have. People are getting 5.19, 5.19. Okay, that is good. Yes. Now, one thing you need to know is that for many of these numbers, once you fail one part, you may end up failing the rest of the parts. So you need to be very careful that you do not make any mistake. So for our first part, 5 point, some are getting, Roslyn is getting 6.3. Oh, okay. Yes. But our first part, we are finding E to G, and many of you ended up with, I think it was 4.24. I think it was 4 point, yes. So we had our E to G, this distance here, we got it as 4.24. So here we had 4.24. And when you look at this line A, E to G, we are forming a 90-degree there. So here you have your 90 degrees. Still we use the Pythagoras theorem. We say your A squared plus B squared is equal to C squared. However, one thing now I want you to start adopting too is that once you find that your triangle, it has the letters already, use the letters that are there. Don't use A, B, C. So now like for this one, I would have said A squared plus E to G squared is equal to AG squared, such that you can define it in the terms of the triangle you have. Then I'll come and I say this is 3 squared plus 4.24 squared is equal to AG squared. Then place your calculator. You don't do it on the calculator because every step counts. So you say this is 9 plus 4.24 squared. I'm getting 19.5364 is equal to AG squared. Then when you add the two, you end up with 28.5364 is equal to AG squared. And then you get your square root, and my square root, when I get it, I'm getting my square root A to G as 5.3419. So my AG I'm getting is 5.3419. And when I round off to the 2 decimal places, I'll remain with 5.34 centimeters. Yes, but when you round off before, you may get an error. So I don't know where people who are getting 5.19. What did you use? Did you use root of 18? When I extract A, C, G, yes, you come up with the same answer. You come up with the same answer. Yes, Matthias. I think people use the 18.
Like, sir, when you square 4.24, you get 17.9776.
4.24 squared.
Yeah, you get 17.9776, but you have got 19.5.
Oh, okay.
Yeah.
Here. Oh, okay. Okay, yes. Thank you. That is correct. Okay. So you end up with 5 point what?
The answer.
9. Okay, the answer. Okay, so this becomes 26.9776. And when you take, you get 5.149.
Yes.
Okay. Yes, so 5.19 centimeters is very correct. Okay. Yes. So we can continue to another part. We are still on the same number. But as we go to another number, now we are going to go and look at the angles. But before we dive into the angles, we need to first remind ourselves a bit of trigonometry. Because now where we are heading, we are going to first apply trigonometry of right-angled triangles. But this simple trigonometry, not the other trigonometry. However, you need also to remember the other trigonometry of the cosine rule, the sine rule, and the rest, because at one point you may need it. So when I have my triangle, I want people to label for me this triangle. To tell me, you just type in the chat, this is my angle, which I'm going to call theta. This is B and this is A. I want you to use the chart to tell me that A is called the hypotenuse, B is called this one, adjacent, C is called this one. Yes, I want you to first label for me those sides in the chart to check whether we still remember our trigonometry.
Opposite.
See, yeah.
So M, okay, 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 perfect, perfect, okay, okay, okay. So it shows that people are remembering very well. Good. Yes. Now, one thing I will remind you that always your longest side on any of the right angle triangles you have will always be your hypotenuse. And then the two sides that make up the 90 degrees, one is either the opposite, another one is the adjacent. But where your angle always faces is always your opposite. And the angle always sits at the adjacent. Now, after this one, I want someone in the chat still to type, how can we remember the three trigonometric ratios? How can we remember what thing do we use to remember all the three? Sine, cos, and tan. That this one is opposite out of this. This one is this. What do we use? Share has told us SOHCAHTOA. Perfect.
Yes.
Perfect. So if you don't know SOHCAHTOA, it means you don't know trigonometry because it is the core. Once you know that, you know trigonometry. Okay, perfect. So good. So everyone at least remembers what we call SOHCAHTOA. Good. Now, this is what we are going to use in order for us to calculate the angles for the next part on that number. Either you use sine or cos or tan, depending on what you have. So we are going to continue, and then now we try out the number. So we are still using the same cube. However, our task now is to find that angle. So always look at the angle you have, and then we find out. So allow me to remove this, and I'm going to ask you now to calculate. But like I've told you, always first trace out what they want. Now they want us to find angle EPA. Now always the letter in the middle is the angle where the angle is located, and that's the angle they want you to find. So we are going to connect E. I go to where E is. From E, they're telling us to go to G. So I move from E, I come to, let me use another color. Let me use red. From E, I'll go to G. From G, we go to A. So I'll go back to A. Like that. So the angle they want us to find is the angle at G. So I'll come and ask, which angle am I forming at G? So this is the angle that they want me to find. And how do I find that angle? I'm going to come back and ask myself. So in simple terms, that's what I have. That is the angle I'm forming. And now you're going to ask yourself, do I have all the requirements? Yes. So I'm going to extract my triangle again. I'm going to have my triangle where I have E, I have A, I'll come down here, I have my G, like that. So I know from A to E, I know this distance. Distance is, let me see whether people have it. A to E, what is the distance? A to E, which distance do we have? From A to E, this distance here. iPhone is telling us it is 3 centimeters. Good. Then what about E to G? E to G, which distance do we have? What did we have? E to G. What did we have? E to G, do we have it? Or we need to calculate 5.1, 4.24? Okay, I think it was 4.24. Good. But still, some people have A to G. That one is also okay. Yes. Also, we have A to G, I think. Did we get A to G? Do we have it? We can as well type it. I think it was the 5.19, if I'm not mistaken. Oh, did we calculate? Okay, I think we didn't, but we can use this, no problem. Now, what you do next? What you do next is that you find this angle they want us at G. I can call it theta. Now, you look at that angle, you ask yourself, which sides do I have? Where the angle faces, how do you call that side? Let me allow to unmute now. Everyone, you can be able to unmute, no problem. So this side where the angle faces, which side is that?
Opposite.
And this is opposite. What about 4.24? Is along which side?
Adjacent.
Adjacent.
Then we are going to go back. Good. So we are coming back to our SOHCAHTOA and we ask ourselves, what relates, because we have opposite and adjacent, what relates opposite and adjacent?
SOHCAHTOA.
What it is? TOA. Is everyone seeing TOA? So meaning we are going to use tan. So I will say tan theta is equal to opposite out of adjacent. Okay. So I will say tan is the opposite
Excuse me,
out
sir.
of adjacent. Yes, please.
What if I first find the missing side and then I use maybe the sin?
It is also okay. It is also okay.
Okay.
Yes, it is also okay. It is also okay. So we are continuing. So I will say tan theta. My opposite is 3 out of 4.24. So you first place your calc. So I'll say tan theta is equal. So 3 divided by 4.24. What do you get?
1.4133 recurring.
You get
1.4133 recurring.
Place well, 3 divided by 4.24.
0.7075.
0.705.
0.0754
Okay. Now here, when you are writing, make sure always you write to at least 4 decimal places. You write to at least 4 decimal. Then the next thing you are going to find is the inverse. I'll say theta is equal to tan inverse of 0.07.
Is equal to tan.
So can we place our calculators and you tell me what you get?
So Greg, we are inverse.
Which angle do we get?
35.2794.
35.2794. Okay. So in your conclusion, when we are writing angles, write them to 1 decimal place. So I write 35.3 degrees.
Tan inverse 0.7075.
Okay. Allow me to mute you now. Yes. So that's how you do it. And that is our angle. So you can first write, and then when you finish, you let me know and we start. Okay, Queen Esther. Okay, people are finished. Yes, so it doesn't matter what you use. Those who have used cos, you have used the sine, given you have found AG, your answers will be the same. Yes, Esther. Esther, unmute.
Okay, teacher, my question is, to how many DPs are we supposed to write an angle? Is it to 1 DP or it can be more?
Okay, now the first thing always you do, first write to many decimal places, like 3 or 4. Then your final conclusion, you write it to 1 decimal place. Because when you go into measurements, and this one being geometry, you cannot measure an angle that has more than 1 decimal place. When you look at your protractor can only measure to 1 decimal place. It cannot measure anything beyond that. So when you have 35 here, you can only measure 35.1 or 2. So you cannot measure to more than 1 decimal place. So that's why our final answers, we write them to 1 decimal place. The same thing applies when you're handling physics practicals. So you write them to 1 decimal place. Hope Queen Esther, it is fine.
Yes, teacher.
Okay.
Thank you.
Okay. Okay. I think people are finished. We are going to continue. Okay. Now this is yours for trying out. So write it and then we try out on your own. When you finish part A, you let us know and you put your answer in the chat, and then we can mark ourselves whether we are getting the same answers. So last time it was a cuboid, it was a cube, this time is a cuboid. So you need to be very careful and not to confuse. So draw and then we try out. Okay, good. People have started getting some answers. Okay, good. Let everyone now keep on trying. When you get an answer similar to what your friends have, then just know you're on track. In case you are stuck, kindly let us know such that we can help out. Always don't forget to draw a line connecting those 2 points. Okay, DSN, I'm saying Sheila, I think Chivelo, Itel, Daisy Victor, Annette, Bagins, they have 5.83. Let's keep on trying everyone and see that we have I'm checking the chart and I want to confirm. Yes. Now, when they don't mention the decimal places, when the question is open and they have not mentioned the decimal places, then write your answer to at least 2 decimal places. At least means you can write to 2 or more. The best can be 4. Yes, whenever they don't specify to how many decimal places to write your answers, kindly write to. Yes. I want to confirm that the answer people are getting is correct. The answer is correct. If that's not what you're getting, 5.83, kindly let us know such that we can open. So the answer I expect everyone to have C to A is 5.830, maybe 95, something like that. So in case that's not what you have, we can hop out. Oh, Monique is saying he's not getting it. Oh, 5.85. Okay. Now we are going to do it. We are going to do the first part A. Now they told us C to A. So I'm going to draw a line from C to A like this. Oh, okay. Let me repeat to draw that line. So that line is coming like this from C, join it to A. So it will come like that. Now, when you look, there are 2 triangles you can form. One, you can form this triangle that comes like to B and it comes like this. So you can either form this triangle A, B, B to C, and then C to A. That's one of the triangles. But what you need to know that this one being a cuboid, this side 3 is the same side here. So here I also have 3. This one being 5, this one is 5 down is 5, also here is 5. The distance for me up here is the same distance, also here there is 5. So here there is 5. So in order for you to be able to calculate for that particular triangle, it means that your hypotenuse is the A to C. So I will say A to C squared is equal to AB squared plus BC squared, which will give us 5 squared plus 3 squared. This will give us 25 plus 9. And when you have 25 plus 9, I'll end up with 34 as my SC squared. So when you get the root, SC will equal to root of 34 is the same as 5.83095. And when you reduce to 2 decimal places, the same as 5.83 centimeters. So that's how we are getting it. In case you're writing to 4 decimal places, and then you write 5.8310. Hope it is okay. Oh, people say, okay. C is now the problem, C to E. Now to get C to E, now here you need to be very, very careful how you can obtain it. I'm going to come, I look at C to E. Let me use blue. I join C to E. C to E is here. Meaning that to get C to E, you're going to form a figure. Which figure are you going to form? Either I'm going to have C to E, then I can come like this, I come like this. That is one approach, whereby I'm going to have my triangle like this, like this, like this, whereby this is E and this is C, this is G. That is one. The other option that you can use is for us to come, you join A to C, C to E, and then A to E. Now, when you use that approach, you need to be very well conversant with like that. Now, when you look at this approach, you may notice that here you do not have a right angled triangle. And whenever you don't have a right angled triangle, life may be very hard for you to find that length they want. So now this one, you first ignore and look for the option that will provide for you the right angled triangle. But one thing we need to always remember that A to C, this diagonal A to C is the same diagonal from E to G. So you have the same answer. So literally, A to C is the same as E to G. So the answer you got for C to A is the same answer for E to G. So E to G here, I'll have 5.83. And then I'm going to ask myself, what is C to G? C to G is the height, which is 2. And therefore, I can be able to find E to C. Kindly let me know whether we have understood in the chat. You can say yes or no. That is good. Okay. So the approach you need to use is to look out for the right angled triangle. You look out for the right angled triangle. You look out for what is giving you the right angled triangle. That is the easiest route to use. Then the last one, angle ACE. Now ACE. Now you draw your figure. So our figure is going to be like this, and then like that. So I have here A, I have C, I have E. And now we are looking for finding out the angle. Let me ask whether people still remember what do you want to use? So here, this one being a triangle and you have all sides, feel free even to use the what? The cosine rule. Because since you have A to C, I don't know what you're getting for A to C. A to C, people are getting 6.16. So this is 6.16. And when you look at E to C, did you have, oh, sorry, I think E to C is 6.16. What did we have for A to C? What was your A to C? A to C, what did we have?
5.83.
5.83. And then A to E, what do we have? A to E?
2.
2. Okay, good. Good. Now, what are we going to do? What do you want to do? What do you want to use? Do you want to first use the cosine rule? Or you want to use the right angle triangle?
Cosine rule.
Cosine rule.
Good. Now, you are going to allow me to draw my triangle in this format. Here we have 2. Here I'm going to just put this is 5.83 and this is 6.16. Now, this is my A. Yes. This is my C and this is my E. Yes. Now, in order for us to find a triangle, one, I'm going to show you all the approaches and then for you to choose what you want. There is no problem. Now, if we are to start with the cosine rule, the angle we are looking for is the angle here, which I can call theta. Then, you need to remember the cosine rule. The cosine rule is labeled like this. In case this is A, this is B, and this is C, this side is what we call small c, this is B, and this is A. So, in case, okay, allow me to ask next people. So in case you are interested in getting angle C, this angle here, which is C, it means I'll say C squared is equal to, can we state it together? Let me see whether people remember. State it together. C squared will equal to people, we can unmute and say C squared will equal to A squared
plus B squared
minus 2AB cos of C.
Cosine rule.
Yes. Now this is our rule. Now we are going to start putting. I've put it exact. So C squared for this case is going to be 2 squared is equal to A squared. A squared can be 6.16 squared plus 5.83 squared minus 2 times 6.16 times 5.83 cos of C. So can we place our calculators? 2 squared we get 4. 6.16 squared we get plus, is it 37?
7.9456.
Plus 5.83 squared we get
33.9889.
33.9889. Minus 2 times 6.16 times 5.83. What do we get? Are we getting 71?
71.8256.
Cosine of C. Now, after doing that, I want us to first deal with these two. Add for me those two. So 4 is equal to, when you add those two, what do we get? Are you getting 71.9345?
Yes.
Okay.
Yes.
Now this is cosine of C. So please, now one of the mistakes usually people make is they subtract the two. You cannot subtract 71 and this one. So the first thing you do, take this 71 this side. So you say 4 minus 71.9345 is equal to negative 71.8256 cosine of C. So I think the background is pretty bad. So that's the first thing you do. So you take the 71 this side first, such that you don't get tempted. So when you subtract 4 minus that, let me hope people are getting negative 67.9345. Is that fine?
Yes.
Cosine of C. So when you reach this point, you divide throughout. You divide through by negative 7. So I'll have negative 6.79345 divided by negative 71.8256. Someone has some background noise. Okay. Is equal to negative 71.8256 cosine of C divided by negative 71.8256. So what do we get when we divide those two?
0.945827.
Okay. That is equal to cosine of C. So the next step is you get the inverse. So can you get the inverse? And you tell us what we are coming up with. So C is equal to cos inverse of 0.94583. So what is our angle C equal to?
18.9451.
5. Okay. So here at 1 decimal place, we shall write it as 18.5.
5.
No,
Ah.
it is
18.4.
18.9451.
Okay. Okay. Yeah, you write it the way you're getting it. You get it.
9, not 449, but is 9451.
It is 49.
18.9451.
Are you sure? Please again. Oh, sorry. It is 18.9451. Oh, okay. So when we round off to 1 decimal place, we get
18.9
degrees. Okay. So can we first write?
Yes.
Have you finished?
Shall we lost
From where?
this side? From here, my connection was poor, so I was lost from here. There,
Where exactly? From?
like where the pointer is pointing down there.
The pointer? Here?
No, this side.
Here?
Yeah, that's there.
Oh, like when we reach at this point, we divide through. So we remove this one here. So I'm dividing it on both sides. So you divide it on both sides. You divide this side by negative 71.8256. Divide this side by negative 71.8256. So when you divide the two, we ended up with this is equal to cosine. And after this point, we go to our calculators. Since we are interested in to remove the cos, so remove it means get the inverse. So we end up with that.
Okay.
Let me hope we are there. Tendoxium.
Excuse me, teacher.
Yes.
Good afternoon.
Good afternoon, sir.
I want some clarification on how we did part B.
Part B, eh?
Yeah.
Okay. Part B, the first thing we had to do is to first find out the line C to E. So when you look at C to E, is this line. Not so? Now, you ask yourself, how can I obtain a right-angled triangle? So the easiest way to obtain right-angled triangle is coming down here and coming like this. So we ended up with that triangle of that nature. Is that fine? Candles, is that fine?
Yes.
Okay, I think, hope that is okay. So allow me now to, yes, lastly, Linda.
Teacher,
Yes.
I wanted to know where you got like 18.9451.
Or like, don't remove. Like when you place your calculator, you press shift cos of 0.9458. What do you get?
Yeah, I'm getting 21.050.
When you press cos inverse, shift
Yeah.
cos of
Yeah.
0.94.
94583.
Oh, now can we first change our calculator? You press shift.
Shift.
Finished. Mod.
Yes. Mod.
Then place number 3.
3.
Press equals.
Equals.
Then press on.
On.
Now
Let
we
me
have
try it
reset our
again.
calculator. We have reset our calculator. You repeat again and you see.
Okay. 8, 3. Thank you, teacher.
Okay. Okay. So, and always, whenever you are dealing with trigonometry, ensure that your calculator doesn't have any other letter up there. It should be cleared. It should have only D. So whenever you find that the letter there is not D and there are many other letters, chances are high that your calculator you may just place and you get wrong answers. Yes, Aitel. Aitel? Okay. I think we can, as Aitel comes.
Sir,
Yes.
I would like you first try to explain something on cosine rule.
Okay. Like you want the application? Oh.
No, the explanation. I'm not well versed with it.
Okay. Let me share my screen and then probably I just take you through briefly. Now, what is a cosine rule? A cosine rule is that rule that we can use in order for us to calculate either the angle of a triangle that is not a right angle. Whenever you find that the triangle you have is not a right angled triangle, the easiest way to find the sides, to find the length, is using the cosine rule. Now, how does the cosine rule operate? When I have, let me say, this is my triangle, or I can even use a shape. Sorry. Wait. Okay. Let me first clear. Okay. Let me share again. Okay. Now, whenever I'm dealing with a right angled with a figure that is not a right angled triangle, let me say this is my figure, and I want to obtain the different things. Let me say I want to do something. Then the easiest way to calculate the sides is using the cosine rule. So cosine rule helps you to obtain the length, the sides, how big the sides are. And how do you do it? How is it labeled? In case this is my triangle A, B, and this is C, the angle that is formed at A is what we call the angle A. The angle formed at B, we call it angle B. The angle formed at C is what we call angle C. Then the sides are labeled depending on which angle is facing that side. Take an example A. When this side where A is facing, angle A, is what we shall call side A. The side where B faces this side is what we call side B. So small letters are the ones that are representing the length. When you look at C, where C faces is what we call side C. So the small letters are representing the length of the sides. Then the capital letters represent an angle. And how is it stated? At this level, you cannot be as, hope my screen is there. Are we seeing the screen? I want to just be sure. Is the screen there?
Yes.
Yes.
Okay. Okay.
Yes.
Okay. Yes. Now at this level, they cannot ask you to derive, but what they can ask you is to apply it. So how do we apply it? It is stated that A squared is equal to B squared plus C squared minus 2BC cos of A. Now, what you need to identify, when you start with A here, this A, the length of A must match with the angle, which is capital A. So those two must match. In case you start with the, let me say, you start with the, oh, okay, a minute. So in case you start with the, let me say B, like B squared, what does it mean? It means you are going to come where there is B instead, you can use A plus C squared minus 2. Now, since you have started with B, B doesn't appear in the product. So you say SC cos of the side you are looking for, which is a B. In case you have started with C squared, then you'll have B squared plus A squared minus 2BA, and then you'll have cos of C. So that's how you use the cosine rule. But some people are saying they're not seeing, but I think I'm going to just stop sharing, and then we shall maybe go through some revision. But it's just a matter of you knowing what the sides are and how to go about them. Which one is which side and how to go about it. Okay. Allow me now to close the whiteboard, and then we go back. So those who are not seeing, I think your screens are not updated. So we are going to another activity, and this is going to be one of the last ones, our pyramid. Now, what if we have a pyramid? I want now each one of us to try out, how do we get C to E? Yes. And now when you look at the pyramid has a rectangular base. So draw your pyramid. I know this one is a bit disturbing to draw it, but let us try to draw it. So I want everyone to first calculate C to E. C to E. Okay, people are getting some answers. So I'm waiting for everyone to reach there. And you tell us what you're getting for C to E. Don't forget, when they don't specify the number of decimal place, first okay. Okay, people are getting. Yes. Baby Jojo, we are applying Pythagoras theorem. So the first thing always you have to do, look out for that particular line they want you to obtain. Look out for that particular line they want you to obtain. After obtaining that line, kindly go on. Kindly go on. Go on. Go on. Yes, I want to test whether people have obtained. People are getting, Daisy is saying 8.54, ITEL 8.54, Malik 8. Okay, I think we are getting there. The rest, I'm saying Alex, Pio, Daisy, Derek, Diana, Emma. What are we getting? Lawa, Joe and Jemima. Are we getting the same answers? Queen Esther, Ricky. Are we getting the same answers? Tom, 8.54. Okay, okay. People are saying Faustin saying it's not getting. Yes, so Faustin, like we said, join C to E. Join C to E. So C to E is where? Is here. Join it. And then look out for a right angle triangle. So mine, I can come like this, I come like this. So I'm finding myself having something like this. I have this, I have this, and I have this. Where I have E, I have B, I have C. So what do I want? I know very well that this side and this side are equal. So here I'll have 3. Here I'll have 8. Then I apply the Pythagoras theorem. So Faustin, I don't know whether that's how you're applying it. Faustin, kindly tell us, are you applying it like that? Okay. I think everyone has reached there, 8.54. Good. Now we are going to go to the next. Hope, Faustin, we are not leaving you. We are going to go to the next. Oh, I think I've jumped something. Okay. The next one is there. We're on the same number. No need to draw it. But what I want you to do is for you to identify that particular thing they want. So here they want us to calculate angle CAX. CAX. So you need to know that that letter in the middle is what gives us the angle. But I'm going to give you a hint. Those who are extracting, I want you to first extract. When you look yourself, CAX, C is here, I join it to A. From A, I go to X. And then I cross my triangle. So you are not seeing, you are getting something like this, this, and this. So roughly it is like that, whereby you have C, you have X, and you have A. Now here you must think, do I have A to X? If I don't have A to X, do I have C to X? I don't have it. Do I have C to A? Now, remember, these are what you call the we call them the edges. So the edges, these ones are okay, are the same for the pyramid. So you don't need. So your CA is going to be 9 centimeters. But your task 1 is that you have only one side, meaning either you must know C to X or you must know X to A. Through the chart, or someone can raise up and you tell us, how do you think CX and CE are related? Someone to tell us, how do you think those two are related? Yes, Queen Esther.
I think CX is a half of CE.
Perfect. CX is equal to a half of CE. Mary, was it the same answer? And Annette, is it the same answer?
I wanted to say X is the midpoint of CE.
AX is the midpoint. Okay, good. Then Annette? Okay, good. Yes, like Mary has told us, X is the center. So CX is a half of CE, is the midpoint, is in the middle. So meaning we shall say a half times our answer we got for CE. I saw people getting 8.54. So kind of, I don't know what we get. Annette, what are you getting? Oh, sorry. Annette, what are you getting?
And CX is the half of CE.
Which answer do you have?
I have 4.27.
4.27. So meaning our CX here is 4.27. Now, after having 4.27, here feel free. For if you want, you can even first find AX. That one is okay. No one refuses you. And then but which angle do we want? We want angle A. This is the angle we want. So can we find this angle A? If you want, you can first find A to X. After finding AX, you use any, either sine, cos, or tan. So feel free to use any. Yes. Annette, do you have something? Okay.
No.
Okay. Yes. Now, feel free to use what you want. Now, in case for me, I have 2, I will know that this side is my opposite, where the angle faces. This longest side is my hypotenuse. So I go back to my SOHCAHTOA 1. I ask myself, what is relating hypotenuse and opposite? And that is sine. So can we first try? First give it a try, and we see what we are coming up with. Which angle are you coming up with? Okay, ITEL is telling us 28.3. Treasure is telling us 25.4. Okay, so let us wait and see what the rest are getting. So everyone is trying. Try. Mary Shani. Mary, you can unmute.
But sir, I thought AX is the one 9.
AX
is 9 centimeter because it is the height.
Is the height. Okay, don't
the
go.
edges.
The edges. But like, let me say, there is the AX is, this is A and this is X, not so?
Yes.
Then when you look at our triangle, how it has been labeled, are you noticing that they are putting 9 here, A to B?
Yeah, I've understood.
So A to B is here. So it's like the hypotenuse. Okay. So let's calculate. Looking in the chart, people are getting 28.3, 25. Yeah, no, we have different answers. 25, 28, 25, 28, 28, 28, 28, 28, 64, 28. Now I'm going to get one. I'm going either to get Nemwa or Big Dad to tell us, or Queen Esther. Who wants to tell us any of those ones? I can start with Nemwa. Nemwa? Unmute. Nemwa? Nemwa, can you talk? Nemwa, we can't.
I'm speaking.
Oh, okay. Nemwa, tell
I
us, how did
divided.
you get 64? What did you use? How you reached there?
I used the tan. I used the tan.
And the
That
tan
is opposite.
Uh-huh.
Divide by adjacent.
Good.
That's
What
9
is the
divide
opposite?
by. That is 9.
Okay.
9
Now.
divide by 4.27.
Oh, okay.
After
now that's
that, I continue.
Okay. Now
Should I continue?
Okay, before you continue, Nemwa, now I want you to know is
Yes.
that opposite and adjacent are always joined by the right angle. I want you to look at this triangle. Where do you think our 90 is? Which point has 90?
X.
X. So 90 is here. So those two lines that join to form 90, those lines are the ones which have opposite and adjacent. So if you don't have those two sides, you cannot use tan. Are you getting it?
Okay.
Yes. Now this one you are mentioning, since it is not joining to form 90 anyway, can never be your adjacent. So what do you think your adjacent could have been?
The adjacent could have been at AX, line AX.
Very good. Very good. Yes. Now that is the first task you are going to do. So first find A to X.
Okay.
Is that okay? After finding A to X,
yes,
you can use your tan. Is
okay,
that fine? So use Pythagoras theorem. Use Pythagoras theorem. Use your 9 and 4.27. Find AX. After finding it, find your tan. Is that fine?
Fine.
Okay. Okay, good. Another person, Big Dad, let me hope it is okay. Yes, Stephen. Maganja Stephen.
But master.
Yes.
I thought that XA is the height of the triangle.
Yes, it is the height.
Yes, they're saying that you're using as the base. I thought that X will act as the base, and then XA as the height, and then CA as the hypotenuse.
Yes, that is correct.
So there I'm getting confused to calculate the to which side to calculate, because when we use the
What are you calculating? You are calculating A to X? Maganja, what are you calculating? A to X? So Maganja, for this case, we would have said 4.27 squared plus AX squared is equal to 9 squared. Then you continue AX squared is equal to 9 squared minus 4.27 squared. Then you make your calculations and you get your X. I think X can be about 7.92, something like that. So that's what you would have done, such that you can use your tan that you want. Is that fine? Okay. 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 Fine. So that's what you have to do for that particular number. So we are going to continue, but those who have used this sign, our answer should be 28.3. 28.3. Okay. Another number is there. So let's find it. I've changed the slide. So some of you may not know. I've changed the slide and we are now on part B. Part B. Part B. Part B. So I want you also to first draw A, D to B. A, D, B. Yeah, and then we try. Try. First draw A, D to B. Okay, I'm seeing people are posting some. Okay, 84.9. Okay, that is 80. Okay, let's keep trying and see what we get. Yes, Mary? Yes, Magaja. Steven?
Yes, I'm getting 84.9.
Okay, 84.9. Okay, what about Mary?
I'm getting 90.
Recording in progress.
You're getting 90. Okay, you're getting 90. Okay, Chiveru Melvin?
I'm also getting 90 months.
90. Okay. Okay. It's okay. It's okay. Okay. Yeah, I think we can do it. Should we start doing it together?
Yes.
Okay. And then we see what we get.
Yes, master.
Okay. Now, see the first thing you do, always connect. It is very crucial, always to connect. Now we want A, D, B. I'll come A. I look out for where D is. A, D, and then B is here. Now, after forming that, I know that the angle that is required is the angle here. If this is the angle required, is like, I don't know whether, let me check whether I have those figures here. And you look at that figure very well. Okay. Now that is the figure I have. So what am I going to do? I'm going to extract, I have this as my A, I have this as my D, I have this as my B. So this is something I have. Then which angle do I want? I want the angle D. What am I going to do? What I can do, I can first come here. I draw and I say this is my 90 degrees. I ask myself, this is where X is, and this is where B is. I first form my right angled triangle. I ask myself, do I have D to X? Do we know D to X? Let me allow you to unmute. Do we know D to X?
Yes. No.
Okay, some are saying no. Okay. How is BX related to DB?
Half of
A half of DB. A half of DB, because it is the midpoint, it's the middle. So, but do we have D to B?
Yes.
What is our D to B?
It is 8.54.
8.54. So I'll say this is times 8.54. Those who don't know, we have gotten D to B. We are using Pythagoras theorem to find it. So here our answer would be
4.27.
4.27. So from D to X, we have 4.27. Then A to D, which distance do we have from A to D? What is the distance here, A to D? 9. Now, what am I going to do? I'm going to just use, and I say what am I going to use? Where the angle faces, we call it the opposite. 9 is what? Hypotenuse. And this is the
hypotenuse.
Adjacent. So when you look at the figures you have 9 and 4.27. So this is hypotenuse, this is adjacent. So you go back to your SOHCAHTOA. So when we go back to SOHCAHTOA, what has hypotenuse and adjacent?
Cosine.
Sine relates opposite and hypotenuse. Cos, adjacent and hypotenuse. Since we have adjacent and hypotenuse, I will use cos. So I will say cos of D is equal to adjacent out of hypotenuse. So I will say cos of D is equal to adjacent 4.27 divided by 9. Cos of D will equal to, what do you get?
1.85.
0.47.
And then after you said D is equal to cos inverse. D is equal to cos inverse of 0.47444. So what do you get?
61.68.
You get?
61.68.
61.68. What are the rest getting? Do we have that answer?
No.
So how did we get the answer we are getting? 90. How are we getting 90?
We used the opposite to be 9.
Oh, you put, okay, I think that was, but the angle you are forming was the angle at D. So you were just cutting out this shape here. Okay. Has everyone understood?
Yes.
Yes.
Okay. Now, what we are going to do, the rest is just your exercise. Now, I know some of you are not on the WhatsApp group. So can I clean this board?
Yes.
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 Okay. Yes. Okay, let me clean. And those who are not on the WhatsApp group, okay, let me even stop. Those who are not on the WhatsApp group can can take screenshots. So for you can take a screenshot. Those who are not on WhatsApp group, you can take a screenshot of the exercise you are going to. Those who are not on the WhatsApp group, you can take the screenshot of the numbers you are going to try out. That's one of the number. You can take a screenshot. These numbers, you are going to try them in your free time. Okay, I think you are finished. That's one. Okay, then the last one is that one. So you try them in your free time. Hey, I have another one, sorry. There's another one here. So you try them in your free time. I think we shall open the group temporarily for some few minutes, and you can share your answers together with your working, and then we can critique what you have done. Okay, let me hope you have finished. The group link, some of you are asking for the group link. Okay, so, but someone I think has already shared the link for group A. Yeah, that is the group, but I'm going to be sharing the slides in that WhatsApp group. I'm going to be sharing, and also I'll be sharing the link. I'll be sharing the YouTube channel where you can find the the work or the recording for the lesson, such that you can be able to review what you want. Someone wanted activity 1. Okay. So I think we are ending here. Unless someone has a question, we shall stop here, and then we shall meet tomorrow for another lesson. Let me wish you a good evening. Okay. Yes. Bye-bye, everyone. See you tomorrow.
Closing prayer.
Oh, okay. Lead us in a closing prayer. Who wants to lead us? Yes, lead us.
أعوذ بالله.
Okay, Nemo, go on. I saw Nemo leading us. Yes, Nemo. Nemo, we are waiting for
Praise
you.
be to Allah, the Lord of the worlds, who has enabled us.
Wanji?
Us more money, but we pray that gives us more life, that we may be able to join tomorrow. We pray that the Almighty bless us with what we've studied, and we benefit from it in future, not to go rest as if we didn't attend studies at. May the Almighty accept our prayers. Amen.
Okay. Thank you so much, Sadida. Okay. Bye-bye,
Excuse
everyone.
me, sir.
Yes, please.
Mister, you said about the YouTube channel. Please, if I have missed, will I be able to access the lesson on the YouTube channel?
Yes, but I think you can check starting at in the evening, around 6. That's when holistic learning platform.
Okay, sir.
Okay.
Thank you.
Okay.
Excuse me.
Yes,
when
please.
they start?
May you please send us the group link? Have not received.
The group link.
Yes.
Okay, let me get it.
Yes, you need a group link, man.
Yeah.
It says the group is full. Use that one. I don't know. Let me check whether it is really full. In case that group A is full, you can use group B. Group A. So group A is full. You can use group B. can use that we have sent. Okay. Okay, we shall start from there. Have a good.
Okay.